understanding and interpreting annuities. Now, annuities are tax-deferred long-term savings accounts. So they're different than a 401k or some other retirement account because with annuities, there's no annual contribution limit. So if you invest money in a 401k or some kind of a retirement, there are different limits depending on your age. So people often will put money into an annuity because it's long-term and there's no limit. So this is our formula. A sub t equals d times the quantity 1 plus r over n raised to the n times t, all of that minus 1, all of that divided by r over n. So this can get a little confusing, but if you have the right calculator, it makes it a whole lot easier. Let's talk about what these pieces mean. Now this here is the amount after t years. So this t inside the parentheses really doesn't mean anything. It just is an informational piece telling you how many years you're doing this. D is the monthly contribution. Okay, so monthly contribution. R is your annual percentage rate. N is the number of in this case, it's number of months, generally. Generally, people will make annuity like deposits every month, so that's 12 times a year, so N would be 12. T is the number of years. So that's what all of these different pieces mean. Now we're going to go ahead and jump in to an example. You start a new job and decide to start depositing into an annuity in addition to a 401k. You deposit $250 a month, earning 5.5% interest yearly. You plan to work 33 more years until retirement. If you deposit monthly the entire 33 years, what will the balance of your account be when you retire? Okay, so I love to start with just saying, what do all these pieces mean? So if I deposit $250 a month, that means my value of D is $250. My interest is 5.5, so that means my rate as a decimal is 0.55. I'm going to work 33 more years. If that's not depressing, I don't know what is. And because we're making monthly deposits, that means N is 12. So once I have this information, I can shove it into my equation. So remember, I'm doing 33 years. So A of 33, that just means the amount after 33 years. That's all that 33 means. There's no math with that. It's a defining feature. And then I plug in. I have my monthly payment, 1 plus 0.055 divided by 12. My exponent is 12 times 33, and then I'm subtracting 1. All over 0.055 over 12. Now, we're going to do this two ways. The first is the easy way. I'm going to show you how to type this into your calculator if you're doing a one-time piece. If you are going to do it piece by piece, that'll be the second part of this video. So, first things first, if you're going to type this into your calculator, you will start with parentheses. And so this is like the numerator. Parenthesis, parenthesis. It gets a little confusing because there's a lot of parentheses, but that's okay. Plus 0.055 divided by 12, parenthesis, raised. So now your calculator might either have the caret button or a y to the x button. One of those is what we need right here, okay? So we do the caret because that tells us we have an exponent. So then I have another parenthesis, 12 times 33. End parentheses, minus 1, end parenthesis, end parenthesis. Okay, so that should be, let me just double check. Yep, that's my numerator. Okay, but we're not done. Then you're going to hit divide because now we're going to the denominator, parenthesis, 0.055 divided by 12, parenthesis. If you have a calculator that can handle all of that at one time, this is what you need to plug in exactly that process. Okay, so if we do that, your calculator will spit out, and we round to the nearest dollar, $279,036.20. So that's great. If your calculator does that, amazing. And if so, end the video and move on with your life. However, if your calculator doesn't do all the steps at one time and you want to watch a step-by-step procedure, please continue. So back to the formula. We've got 250. 1 plus 0.055 divided by 12 raised to the 12 times 33 minus 1 all over 0.055 divided by 12. Okay, so we need to work in our numerator first, order of operations. So first things first, I'm going to do this exponential piece. So 12 times 33 is 396. So I've got 250, 1 plus 0.055 all over 12 raised to the 396 power minus 1 all over 0.055 over 12. Now, part of this process is kind of doing it in chunks. Okay, so that was the first chunk that we did. The next chunk is going to be this inside piece. Okay, so inside the parentheses, we're going to take the 0.055 divided by 12. Okay, so 0.055 divided by 12, you're going to get a little decimal answer. Add 1 to that, and you're going to get a 1.00458 in some business, and then we're going to raise that to the 396th power. Okay, so this is our first piece. We're just doing this inside. So now we have 250, parentheses, 6.115663645, blah, 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 minus 1, all over 0.055 over 12. Okay, so now we're still inside the parentheses. Let's go ahead and subtract 1. Okay, so now I have 250 times 5.115663645. And you want, this goes on forever, but you want to keep as many decimal places as possible. So now in the numerator, let's multiply 250 times that 5.111. And we end up with a numerator of 1,278.915911 divided by 0.055 all over 12. Now, at this point, we should be able to type this in all at one time. So we would take 1278.915911 divided by parenthesis 0.055 divided by 12. And that should also give you the answer that we had earlier, which is 279,030, there's a comma, 36 and 20 cents. So no matter which way you do it, you get the same answer. Thank you.